Okay, so today we're going to be talking about two things. This is going to be section 5. The first thing that we're going to talk about is the exterior angles of polygons. Okay. All right, get your notes out. Get your notes out. Put it away, Julian. Julian, put it away. Okay, so we've talked about the interior angles of a polygon. When we talked about the interior angles, what was that equation we used to solve?
Oh.
Yeah, n minus 2 times 180 was for the interior angles. Now, when we have exterior angles, do you remember like what kind of angles are those?
Exterior, like they were like split off.
It's like they're on the outside. Oh, whoops. I didn't say you were wrong. Oh. Yeah. What? Okay, just get a different notebook out. Just get a piece of paper then. Okay. So if I have this type of triangle, okay, what kind of triangle is this? It's a hexagon. Okay. Now, here's where we got to pay attention for exterior. Now, if we say that the lines keep going, because like inside, these are the interior angles, okay? Just like right there, okay? When we talk about the exterior angles, if I keep going with this line right here, okay, the exterior angle will be right here, okay? So those would be the exterior angles. Okay, do we see those? Because do you remember when we talked about triangles and like if we had this line and it kept extending, this is the exterior? That's pretty much what it is. Okay? It's just going to be just like that. We're solving for the exterior.
Every single exterior, but they're all the same.
Not only if it's a regular polygon. Okay, here's where I need you to pay attention. When we are talking about exterior angles, oops, what? I just mixed the two words. Exterior angles. The exterior angles of any polygon. Any polygon equals 360 degrees. Any polygon. So, if I have a pentagon, what are the exterior angles going to add up to equal? 360. What if I have a dodecagon? 360. Huh? That's what I just said. Anytime the exterior angles equal 360. Now, what if I said, okay, I have this regular, let's say this is a regular hexagon. If I have a regular hexagon, what are each individual angle, what are they going to equal? How am I going to solve for that? No. 360 divided by 6. Because if it's a regular, they're all going to be the same value. So what's 360 divided by 6? 60 degrees. So each angle would equal 60 degrees. Now, what if I said I had a polygon? Oops. I had a polygon, and each individual angle equals 40 degrees. Okay? How can I figure out how many sides is that polygon?
4 times x equals 40 times y equals divided by 4.
Yeah, which is, you could do the same, which is setting it up. So Julian said 4 40x equals 360. Okay, which is just 360 divided by 40. So x, how many sides does this polygon have? 9. Okay, do you see what we're doing there? Okay, that's pretty much it with the exterior angles. So let's go ahead and look at a couple example problems. Let's look at this one right here. We want to find the measure of each single exterior angle of this regular polygon. So let's figure out how many sides is this polygon. I moved it, I know, I'm sorry. Okay, so it's 9. So what do we do to solve this one? 40 degrees. Okay? Not every time it's going to be a whole number. So just make sure you pay attention if you need to round to the nearest tenth. What about this one? The exterior angle of a regular polygon measures 72 degrees. How many sides does this polygon have? Yeah, I need to do 360 divided by 72. So what's 360 divided by 72? This is 5 sides. Yeah, pretty easy. What if we have a question like this? Find the measure of the single exterior angle of a regular 11gon. What do we do here? 360 divided by 11. And what is that? Okay, perfect. Here's the only one that we really didn't talk about, this next problem. The measures of the exterior angles of a hexagon are x, 2x, 3x, 7x, 8x, and 9x. Find the measure of the largest exterior angle. Now, this just has, okay, the measures of each of them. So this is not a regular hexagon. Okay, so this time all the angles are different. Well, what did we say the exterior angles always equal? So we're going to add all of these together and equal it to 360. So I need to do x plus 2x plus 3x plus 7x plus 8x plus 9x. And that equals 360. Sorry, I got a little small there. So if we add all those numbers together, what is that going to be? Do we get 30x? 30x equals 360. Now what? Yeah, divide by 30. And what's 360 divided by 30? Is that my answer? Yeah, I need to find the largest exterior angle. So I need to do 9 times 12. Do we get 108? Okay, there we go. Okay, just make sure you pay attention to this point right here. All right? Yeah. Correct. Okay, do we have any questions on exterior angles? Okay, that's it for exterior. Now let's move on to our next part. Yeah, those aren't too bad at all. It's not proofs. Not proofs. No. This is just part of 6.5. It technically is 6.6, but it's just going to be 6.5 as well. Okay. Now we're going to go back to just focusing on quadrilaterals again. This is going to be rhombus and parallelogram properties. So what we're going to be focusing on is we're going to be focusing on the sides and angles of both parallelograms and rhombuses. Okay, now when we have a rhombus or a parallelogram, okay, what makes a parallelogram a parallelogram? Two sets of parallel sides, okay? But what else can make, if we didn't know that they were parallel, what else could tell us if it was a parallelogram? Or, if we focus on parallelograms, okay? Now, the main thing about a parallelogram is what Charlotte said, is it has two sets of parallel sides. So it would look something like this. Now, if these two sides were parallel, and these two sides are parallel. Now, another way we can identify a parallelogram is if we have two sets of congruent sides. Okay, so if we have two sets of congruent sides, we can say it's a parallelogram. Okay, so the one thing that we're going to be focusing on is the sides of a parallelogram. Okay, so if I have a parallelogram, and let's say this side is 23, this side is 7, okay, I need to find x and y. What is x going to be? 7. What is y going to be? 23. Okay, the sides are going to be really easy. Okay, so I'm just going to have the word sides there. What makes a rhombus a rhombus? Yeah, it has 4 congruent sides. Okay, so if I have something like this, oops, those don't look congruent, but they'll be fine. Okay, so all the sides are congruent. So if I have a rhombus, all right, and let's say that this side is 8. What is x going to be? What is y going to be? Z? Pretty easy, okay, right? Sides are going to be pretty easy. Now, let's talk about the angles. When I have a parallelogram or a rhombus, what do the angles on the inside of those quadrilaterals have to equal? Not 180 because it's not a triangle. 360. Because if we do, how many sides is a quadrilateral? 4. So think of it as 4 minus 2 times 180. Julian, put it away. So what's 2 times 180? Yeah, 360. So anytime we're dealing with a quadrilateral, all right, those interior angles add up to equal 360. I was just showing what the interior angles add up to equal. Okay, so when I have a shape like this, let's say that this angle right here, I'm going to say it's 133. Now, what if I told you we can find all the rest of the angles? Okay, now, when we are working with these parallelograms and the rhombuses, okay, the opposite angles are congruent. So what angle is opposite from 133? Y. So y would equal what? Okay. Now there's two ways that we can approach this. I'm going to tell you the hard way first. Okay. Well, if y is 133, okay, what can we say about x and z? They're also congruent, okay? The hard way we can do this is we can do 133 plus 133, okay? And what's that? Okay? So 266. And we could say that plus x equals 360. So then we would subtract 266. And what's 360 minus 266? Okay, and then what would I have to do with this 94? Divide it by 2. Because then that gets me those two angles. Okay, and what's 94 divided by 2? It'd be 47. Okay, so we can find out that those angles are 47 based on that. Okay, the easy way we can do this is the angles that are next to each other. So let's say if I have this x and 133, they add up to equal 180. So I could do 180 minus 33 to find x. So what's 180 minus 133? 47. Now that works with these two as well. It works with these two. It also works with these two. Okay? So you could approach it in a lot of different ways. All right? But just know the angles that are next to each other, they add up to equal 180. All right? These add up to equal 180. These. Okay? Then the diagonals across from each other, all right, those are congruent to each other. They are equal. Okay? Do we have any questions about these so far?
Yeah, how do we have to know that it's a parallelogram and a rhombus.
Yeah.
Like you have to have the lines drawn out.
Yeah, it will tell you, like, it'll have the congruent marks. Okay? Eventually we'll get to trapezoids, and for some of the sides of a trapezoid, they're going to add up to equal 180 as well, but not every time. Yeah. They're congruent to each other. Let's look at some examples. Okay? This one, it says, what are the two missing sides of this parallelogram? Let's find x first. What's x going to be? It's going to be 38, okay, because those two sides are congruent. What's y going to be? 76, because those two sides are going to be congruent. Okay? What about this one? Which one do I automatically, should I know right away? Z. What's z going to be? Now, how can I find x? Yeah, I can do 180 minus 73 because these add up to equal 180. And what's that going to be? 107. So if x is 107, y is 107 because they're congruent. Okay? What about this one? Since it's a rhombus, what makes a rhombus a rhombus? Four congruent sides. So x, y, and z are all 93. It did. I wasn't trying to. And then finally, what about this one? Which one do I automatically know? Z is 69. What about y? How can I find y?
69 plus 1.
So 180 minus 69, what's that going to be? And then that makes which other, that was y, so that also makes x 111. Okay, now, I don't want to make it too easy for you guys, okay? So let's add some algebraic. Don't say, oh my gosh, say woo. So, I need to find x, y, and z on this one. Now, let's start with y. How can I set this up to start for y? Yeah, the diagonals equal each other, okay? So, if this angle is 85, let's put 4y plus 1, plus 1 equals 85. I subtract the 1, divide by 4, and y equals 21. Now, how can I find x? Wait, yeah. These equal 180. Okay? So let's just go ahead and we can do 8x minus 1 plus 85 equals 180. So I'm going to add my combined like terms. So I have 8x, do negative 1 plus 85. So 8x plus 84 equals 180. I subtract 84. What is 180 minus 84? And then I divide by 8. x equals 12. Now, I need to find z still. So, what do I know? How can I figure out what this angle equals? Yeah. If I plug in my x here, 8 times 12 is what? 96 minus 1. So this equals 95. So I have negative z plus 1 equals 95. I subtract my 1. So z equals what? So here's my z. It's not negative angle. Z equals negative 94. Well, this equation says negative z plus 1. If I plug in negative 94, it's negative. So what happens when I have a negative times a negative? Positive. Okay? So some of these are going to be tricky with those negatives. So we have to pay attention on when it has a negative. Okay? Because if you put 94, it would be wrong. Okay? What about this one? How would I solve for x? Yeah, this one's a parallelogram, so I would do 51 equals, well, these are going to be equal to each other, so 5x plus 6. I subtract my 6. What's 51 minus 6? Perfect. What about y? Yeah, these also equal. So 92 equals 4y plus 4. I subtract my 4. And that's what I would do for those sides. Okay? These aren't angles. So, yeah, the sides you're just going to have to pretty much just set them equal. Angles are when you're going to have to actually find the values. Do this one on your own. Yeah. You can do either or. Just know that these are congruent, the diagonals, and then these add up to equal 180. Pretty much, yeah. Well, it just depends on what you're given. Like, it depends on, like this one, you have to do the diagonals and the 180. Well, because you have to find x, y, and z. Yeah. Yeah, but you still have to find X, Y, and Z. It says find the value of X, Y, and Z. You can't just tell me the angle values because then that's not right. No, I know, but you're just saying if I say this is 107 and this is 73, this is 73, that's not right because it asks you to find X, Y, and Z. No. You have to find the angles in order to solve. Mm-hmm. But you need to get in the habit of showing your work. Mm-hmm. You need to though. It's not too complicated. You're gonna miss so many points next year if you don't start showing your work. I know, but next year in Algebra 2, you have to show work. So I need to get you into that habit now. Oh, negative 6z plus 1. Mm-hmm. Yeah. The angles? Well, you found x. X is negative 83. But that doesn't mean the angle's negative 83. X, Y, and Z. Yeah, pretty much. Not yet. All right, let's go ahead and talk about the answers. What do we get for x? We should get negative 83. Oops. Oh, I said I know. I knew I did something wrong. Sorry. That's how you should set that one up. Okay. That's how you should have set that one up. What do we get for y? But just you add you do 107 minus 10. So that's going to be 97 minus x. Subtract 97. This is going to be 70. Or no, it's not 73. This is 83, right? Yeah. No, this is 83. Equals negative x. Divide your negative. Yes. Because it's negative x right here. So a negative times a negative. All right, do we all get 18 for y? What do we get for z? Negative 12. Because it's negative 6 right here. It's not a negative angle because negative 6 times negative 12 is a positive. Because then that's 72 plus 1, which is 73. Yes. Okay. Take your time on this. Now, on those quadrilaterals, okay? On those quadrilaterals, in Google Classroom, it is so important to look at this for those ones that you solved yesterday, okay? Because this is going to be able to help you identify on, like we talked about today, both pairs of opposite sides are congruent, okay? We can identify a parallelogram based on that. A lot of people are being thrown off by when the diagonals bisect the vertex angles, okay? When the diagonals are congruent, all right? Make sure you look at this because these are going to be this is what's going to be able to help you solve those questions that you had yesterday. Okay? Now, when I am gone, all right, you guys are responsible for working on the homework and what I assign. So there's no reason that some of you shouldn't have, like some of you didn't even open the assignment. Okay? I don't appreciate that. All right? You have to do your work when I'm gone. I assign that for a reason. And I give you the whole class to do it. So you don't need to be working on playing games the whole time. That's not what you have class time for. Okay? So if ever I'm gone again, there will be consequences if you're not doing your homework. Okay? Now, before you get started on homework, okay, close your computers. I never told you you can get them out.